Hello everyone and welcome back to the sessions on fixed income. In continuation of this topic, term structure and interest rate dynamics, or you title it as term structure of interest rates, we are just going to focus in this particular class on forward rates and forward pricing. If you can recall, in the previous class we have mainly learned how to determine spot rate and how to determine the spot price or the current price. So spot price, spot rate, sorted. Now we focus on the forward price and forward rates. So typically what is a forward rate? I have explained to you already. Suppose I want to borrow and I want to borrow not immediately but at a later stage. Say I want to borrow for a period of 3 years but not now, after 1 year. So I approach a bank and request the bank to agree for a committed forward rate or interest rate that will be applicable for such borrowings. That means borrowings will initiate after 1 year, but the rate is agreed today. In that case, such a rate is called forward rate, and the agreement between the borrower and the lender is called forward rate agreement. Now, once you understand what is a forward contract or a forward rate agreement, and you also understand what are forward rates, the next aspect that you need to learn is how to determine such forward rates. What is the connection between the spot rate and forward rates? So let us do one thing. Let us first write some notes under the heading forward rates. So please write forward rates. A forward rate is an interest rate agreed to today for a loan to be made at some future date. The annualized interest rate on a loan to be initiated at a future period is called the forward rate for that period. The term structure of forward rates is called the forward curve. See, exactly the way the term structure of spot rate is called spot curve, the term structure of forward rates is called forward curve. As the forward curves and spot curves are related mathematically, we can derive one from the other. Let us move ahead and continue writing further. Consider the following notation. When I write this term f j comma k and j comma k within brackets as subscript, how do you interpret this? Please understand one thing. When I write small f, it indicates a forward rate. If I write capital F, it would indicate the forward price. So FJK is the annualized interest rate applicable on a K year loan starting in J years. So please understand this timeline. Currently T equals to 0. There are two different timelines where T equals to J and T equals to J plus K. Now please observe this point very well. The time span from t equal to 0 to t equal to j, the gap between this is j years, and the gap between t equal to j and t equal to j plus k is k years. So if you want to borrow for k years but after expiry of j years, the applicable rate is mentioned as fjk, that is j comma k. So let me explain this via an example. F23. How would you interpret this F23? It is the annualized interest rate applicable on a 3-year loan starting in 2 years. That means the loan will initiate after 2 years and loan will be for a period of 3 years. So again, if I draw the timeline, currently the time is 0 year. After 2 years, the borrowing will initiate and the borrowing will be for a period of 3 years. So when I write these three timelines, look at this. T equal to 0. Right now it is the date of agreement. When t equals to 2, it is the date at which the borrowings will initiate, and when t equals to 5, it is the date at which the borrowing will terminate. So what is the duration of the borrowing? It is from t equal to 2 to t equal to 5. That means it is for this gap, that is 3 years. So the duration of borrowing is always considered as k years, and the number of years after which you initiate your borrowing is J years. Let us move ahead and continue further. Interrelationship between spot and forward rates. Now this is something very, very important. Please pay attention. Let us consider a timeline starting from 0 and spreading to year 1 and year 2. And suppose the applicable interest rate for the period 0 to 1 year is 6%, and the applicable interest rate from year 1 to year 2 is suppose 8%. So do you know what will be this 6%? This 6% will be the spot rate applicable for 1 year. So we will call this as S1 or Z1. But this is not a spot rate. Why it is not a spot rate? It is not a spot rate because it represents the applicable interest rate that will start after 1 year, and it will be for a period of another 1 year, because the borrowings are supposed to start after 1 year from now and terminate after 2 years from now. That means J plus K is 2 years, J is 1 year, that means K is also 1 year. So this 8% mentioned over here is the interest rate applicable for 1 year borrowing that will initiate after 1 year. So this will be not considered as a spot rate but a forward rate, and we write this as F1,1. Why 1,1? Because 1 year loan starting after 1 year. This first one in this term, the first one indicates J, that is the period after which the loan initiates, and the other one is the duration of the loan. So it is F1,1. Now let us assume that the initial amount of loan is say $1,000. Now if this loan is borrowed now, that is at 6% for 1 year, what will be the maturity value after 1 year? Without even using your calculator, you can mention that the maturity value after 1 year will be 1,060. Now, how do we get that 1,060? It is $1,000 that you have borrowed initially into 1 plus I, that I is the spot rate applicable for the first year, that is from 0 to 1 year. So once you arrive at the maturity value, that is 1,060. Now this value, if it is borrowed at this point of time, from here to here, that is from the end of year 1 to end of year 2, the applicable interest rate is going to be 8%. So what you are going to do, to arrive at the maturity value of that loan at end of second year, you are going to add 8% to 1,060. When you add 8% to 1,060, indirectly you are multiplying 1.08. When you are multiplying 1.08 to 1,060, what you get is 1,144.8. Now try to connect the initial amount borrowed, that was $1,000, with the final maturity value at end of 2 years. So if you connect $1,000 with $1,144.8, what would you get? You would get the connecting interest rate as the interest rate applicable from 0 year to 2 years. When I say from 0 to 2 years, means the loan is initiating right away. If the loan is initiating right away, means it is a spot rate. So you are connecting from 0 to 2, you are going to compute a spot rate over here. So the applicable interest rate will be Z2, because Z2 or S2 will be the spot rate for 2 years. But look at the pattern of computation. On 1000, what factor would you multiply to arrive at 1144.8? You will multiply 1 plus Z2 raised to 2, because compounding will happen once every year. Z2 or S2 will be the spot rate for 2 years, but because compounding is going to happen, you are going to take the base amount as $1,000 into 1 plus Z2 raised to 2. So the point is, I was knowing what is Z1. I was also knowing what is F11. What I don't know is Z2. But once you connect these values, it is easy for you to determine the Z2. Why and how? Simply put, on $1,000, when you multiply this factor, you will be getting this value, correct? So 1000 into 1 plus Z2 raised to 2 would give you 1144.8. So how would you find Z2? Through that equation, you can determine the value of Z2, and I'm going to show you that right away. But before I show you the calculations, please write up this presentation in your notebooks quickly. Let us move ahead and now make the calculation of Z2. As I have explained, 1000 multiplied by 1 plus Z2 raised to 2 would give you the final maturity value at end of year 2 as 1144.8. So 1 plus Z2 raised to 2 will be 1144.8 divided by 1000. So 1 plus Z2 raised to 2 will be 1.1448. So 1 plus Z2 will be basically square root of 1.1448. When you do that calculation, 1 plus Z2 comes to 1.069953, which you can round off to 1.07. So if 1 plus Z2 is considered as 1.07, Z2 will be 1.07 minus 1, and that will be 0.07 or 7%. Let us move ahead, and now we try to apply something beyond this. So Z1 is 6%, Z2 is 7%. If I ask you to find the discount factors through these spot rates, I'm sure you remember what are discount factors. When you are considering zero coupon bonds with par value as $1 and you have 1 year spot rate as 6%, what will be the price of that bond which has a par value of $1? The price of the bond today will be nothing but the discount factor, means it will be $1 divided by 1.06. Likewise, if I have to find discount factor for the second bond that is having the spot rate for 2 years as 7%, what will I do? I will take 1 divided by 1.07 raised to 2, correct? I am just going to compute the present value factors or the discount factors. So let me just help you with the calculation. DF1 or the discount factor 1 will be 1 divided by 1.06, that is 0.9434, and DF2 will be 1 divided by 1.07 raised to 2, that will be 0.8734. Now let us try to understand the implication of these discount factors. Again, let us consider the timeline starting from 0, then after 1 year lapse, which is exactly at the middle, then we have the timeline terminating at 2 years. So just imagine if the bond is maturing in 1 year time, so at 1 year end the bond will have the par value of $1. So the present value of that will be 0.9434. Likewise, if the bond is maturing at 2 years time, at that date, that is after 2 years from now, the par value of the bond will be $1 and the present value of that will be 0.8734. So 0.8734 is nothing but the discount factor for 2 years, and 0.9434 is the discount factor for 1 year. Now, most important thing, if I want to connect something from year 2 to year 1, what it would be? So assume that this bond which is maturing at second year end, which will give you $1 as the par value, its value at present is 0.8734, but I would want to find its value over this point of time. So when the bond is going to give you the par value realization in your hand as $1 at end of second year, what would be its value at year 1? For computing this value, you should first of all know what would be this particular value. In other words, conceptually, what would you call that value as? That is not the spot price of the bond, it is the forward price of the bond. When I say forward price of the bond, it is basically the bond's price that will prevail after 1 year, and the bond from that point will mature in 1 year, correct? Or you can say it is the discount factor of $1, which is for a 2 year bond, but discounted not by 2 years, discounted by only 1 year, correct? In that case, this question mark value, if you want to arrive at, it will be capital F1, 1, means it is a forward price for 1 year loan starting in 1 year. I repeat, forward price for 1 year loan starting in 1 year, or forward price for 1 year bond which will initiate after 1 year. And you know what you have done? You have taken the two factors, the two discount factors. The DF2 was taken as the numerator and DF1 was taken as denominator, and final value what you get is 0.9258 is the discount factor. Now, what mathematically we have done, in the numerator we have taken DF2 and in the denominator we have taken DF1. You should know one thing, that DF2 can also be termed as P2. DF1 can also be termed as P1. So if you are taking P2 divided by P1, you are going to get F1, 1. F1, 1 is the forward price of 1 year bond after 1 year from now. Now, right now, this may sound a little bit confusing to you. You just observe all the calculations and connections ahead. We will connect each of these dots and finally prove it mathematically and by calculations that if you want to arrive at the forward price, this is the best way to arrive at the forward price. So before I take you to that further explanation, I would want you to quickly write up this whole thing. Let us move ahead and now analyze things further. If F1, 1 can be computed by taking 1 divided by 1 plus small f1, 1. Now what exactly is this? This is the forward price for 1 year initiating after 1 year. If you want to find that, it is basically the present value of this $1 discounted only for 1 year, but discounted using not the spot rate, because you don't want to land up to the present value of that bond at present. You would want to arrive at the present value after 1 year from now. That is why we don't call it P or DF, we call it F. Capital F indicates the forward price for 1 year initiating after 1 year. So we have already obtained this value, and that is 0.9258, and that will be 1 divided by 1 plus f1, 1, and by cross multiplication 1 plus f1, 1 would give you 1 divided by 0.9258. When you apply this calculation, you get that value as 1.08. So f1, 1 will be 1.08 minus 1, that will be 0.08 or 8%. So basically, you were supposed to get this answer itself. Why? Because I am still continuing with the same example which we initiated with. You remember, we have initially drawn a timeline where the interest rate from 0 to 1 year was 6%, and from year 1 to year 2 it was 8%. I have carried on the same example because through that example we have computed Z2 as a 7%, and when we made these calculations we took Z1 and Z2, and through that connection we have arrived at the forward rate, that is small f1, 1. Now please be careful about the variables used over here. Small f will indicate the forward rate, whereas the capital F will indicate the forward price. On the other side, if you take small s or small z, it will indicate the spot rate, and if you are taking capital P, it is indicating the spot price. So be careful with all these variables as well as calculations. Just let me give you some time to note down this whole thing, and then I take you ahead. Let us move ahead and take up the next example, that will be example number 7. Now, I am not going to directly solve this example for you. I want you to carefully read this example, and based on whatever you have learnt, you try attempting these calculations, and let me check after a while whether you have got it correct or not. I'll give you exactly 3 minutes to try this calculation. Let us check your calculations. Determine the 1 year discount factor. This is very simple. You have learnt it very well. The answer comes to 0.9346. 3 years discount factor. Easily you can compute again. The 3 year rate is basically 9%. That is 3 year spot rate. So what you will do? 1 divided by 1.09 raised to 3, and that gives you 0.7722. Once you get DF3 and DF1 both, then easily you can determine the forward price of a 2-year bond to be issued in 1 year. So you have to compute basically F1 comma 2, that is capital F1 comma 2. So in the numerator you will be taking the discount factor for 3 years, in the denominator you will be taking the discount factor for 1 year, and it will give you 0.8262 as your final answer. So please write up these calculations, and later stage we are going to logically compare these all factors and prove it mathematically. For some of you, this, as I told you earlier, could be little confusing by far, but the moment I step into the two important models, that is the forward rate model and the forward pricing model, and when you are able to join the dots, you will be completely clear with the whole matter. And this is something that will require lots and lots of revision and practice, but keep an open mind, and don't depend on formula based learning. Try to understand the concept. So what I'm going to do is I'm going to introduce to you the forward pricing model and later on forward rate model, where you can compute something through formulas, but initially we don't want to depend on those formulas. We want to logically understand the whole set of calculation. So let us first write up the heading. In your notebooks, please write this heading, the forward pricing model. And what exactly does this mean? The forward pricing model values forward contracts based on arbitrage free pricing. Now, what is arbitrage free pricing? Let us move ahead and consider some notations over here. We have already written one thing earlier. Small f j comma k indicates the annualized interest rate applicable on a k year loan starting in j years. Correct? It is a k year loan starting after j years. So on this timeline, this period is j and this period is k. So loan will initiate after j years and loan will be for a period of k years. So if this point of time is t equal to 0, obviously what will be this point of time? It will be t equal to j, and this is already t equal to j. This period is k years, so this time point will be t equals to j plus k. Now when we talk about small f, it is the forward rate, but when we talk about capital F, it is the price of the bond. So capital F j comma k will indicate the price of a k year forward contract after j years, but the price has to be determined today. So f j comma k, capital F j comma k, is basically used for determining such forward price which will be determined today, but it is applicable for a later date. The objective of this particular calculation is what we identify as forward pricing model. Let us move ahead, and now let us take examples to understand this whole concept. Consider the following example of two investors A and B. Investor A purchases a $1 face value 0 coupon bond maturing in 3 years at a price of P3. Now this can be symbolized as P3 or DF3. Either way it is one and the same. Investor B enters into a 1-year forward contract to buy a $1 face value 0 coupon bond maturing in 2 years at a price of F1, 2. Please understand one thing. Both of these bonds are 0 coupon bonds. Both will mature after 3 years from now. But this bond is initiating right now and will mature in 3 years. This bond will initiate after 1 year and will mature after another 2 years from the date of initiation. That means the maturity date of both the bonds will be same. Now, investor B's cost today is the present value of the cost. So, present value of cost will be PV of F1, 2. Now, F1, 2, you want to convert this in terms of present value. So basically what I am trying to explain over here, again don't get carried away by notations and formulas. try to understand this logically. I am focusing on investor B. Investor B is buying a bond which will initiate after 1 year, and from that point it will mature in 2 years. So from now, the bond will have the maturity date 3 years from now, but the bond hasn't initiated yet. Bond will initiate after 1 year. So we are trying to determine the price of that bond today that will initiate after 1 year. So we don't want today's price, we want the price after 1 year. So that will be capital F1, 2. That means initiating after 1 year and for a period of 2 years. So capital F1, 2 is basically the value of that bond after 1 year from now. If you want to find its value today, what you should do? Tell me. You should divide it by 1 plus S1. What is S1? Spot rate for 1 year. And when you take 1 divided by 1 plus S1, you are going to get nothing but DF1 or P1. You know, DF1 or P1 indicates the discount factor for 1 year. Everything what I have discussed, if you have connected all the matter by now, you would have understood the whole crux already. Patiently listen to me. Once again, we are taking examples of two investors, one who is investing right away in a 3-year bond, one who is planning to invest after 1 year for a period of 2 years. Both of the investors will getting the maturity value as $1 in their hand after 3 years from now, where investor A has already made investment, investor B has not made investment, investor B is yet to invest after 1 year for a period of 2 years. Investor A will get back $1 after 3 years from now. Investor B will get back $1 after 3 years from now. But the only difference is investor A has already made investment and investor B is yet to make investment. Now you tell me, what is the amount that investor A would have invested? Use your common sense. So you identify the spot rate for 3 years because investor A has invested in a 3-year bond. You identify the spot rate for 3 years and you find the discount factor for 3 years. So it will be $1 divided by 1 plus S3 raised to 3. So you will get discount factor for 3 years. That is basically P3. That is, you have computed the discount factor for 3 years. That is the amount invested by investor A. Investor B hasn't invested a single penny now. Investor B is going to invest after 1 year. So you have found how much money investor B will invest. Because the money is not getting invested now, it is not the spot price or the current price, it is the forward price. So capital F1, 2 indicates the price of a bond which will initiate after 1 year and will be there for a period of 2 years. F1, 2. Capital F1, 2 is the price that investor B will have to pay after 1 year from now. But we want its present value. So what you will do? You convert 1 year value into its present value by applying 1 year discounting. And for computing that 1 year discounting value, you take 1 year spot rate, correct? You take 1 year spot rate and you take capital F1, 2 divided by 1 plus S1, or 1 divided by 1 plus S1 will give you DF1 or P1. That is the factor for 1 year, discount factor for 1 year, or the price for 1 year zero coupon bond. Now what you do? The discount factor for 1 year you multiply to the value that you have to pay after 1 year. You will be getting the present value. And therefore, focus on this particular equation that I am trying to explain. Look at this. The present value of F1, 2 will be F1, 2 into P1. When I say into P1, it is basically the discount factor for 1 year. Now, look at the next line, which is very, very important line. Because the $1 cash flows at 3 years are the same for the two investors, these two investments should have the same price, which leads to the forward pricing model. That means how much did investor A invest now? P3. And how much did investor B plan to invest after 1 year, that is F1 comma 2, but its present value is P1 into F1 comma 2. That means P3 will be equal to P1 into F1 comma 2. Therefore, from this, if you want to find the value of F1 comma 2, it will be P3 divided by P1. Now this is what we call as no arbitrage pricing, and that is the base for the forward pricing model. I want you to just carefully understand and note down this whole thing. Don't write it as a formality. Understand and write it down, and then only we shall proceed ahead. Let us move ahead and conclude the forward pricing model. So please carefully understand this part as well. As per what we have discussed through that example, Pj plus k will be equal to Pj into Fj comma k. Correct? Look at this. This was P3 in our example. And what was P3? Do you know? It was P1 plus 2 equals to P1 into F1 comma 2. If you recollect what we have done in the previous example, exactly from that we are deriving this equation. So Fj comma k will be Pj plus k divided by Pj. Now that was forward pricing model concluded. And now the forward rate model. The forward rate model relates the forward and spot rates as follows. Now you have already learned how to compute the forward rate from the spot rates. So it is basically 1 plus z j plus k raised to j plus k will be equal to 1 plus zj raised to j into 1 plus fj comma k raised to k. Or you can compute the forward rate like this. Now this again might appear confusing for you, but you have already learned how to apply it in earlier examples. So this whole notation, if you can consider it through examples, you will be having much better understanding. For example, if j is 1 year and k is 2 years, so then this will be f1 comma 2. So it will be 1 plus f1 comma 2 raised to 2 multiplied by 1 plus z1 raised to 1 would actually give you 1 plus z3 raised to 3. So 1 plus z3 raised to 3 is 1 plus z1 raised to 1 into 1 plus f1 comma 2 raised to 2. You can again check with your calculations made earlier in the content what we have discussed. Let us proceed ahead, and now we try to define interrelationship between spot and forward rates. We have already discussed something like this earlier, but in a timeline earlier I took year 0, 1 and 2. Now I am taking year 0, 1 and 3. Assume that the applicable rate for the period 0 to 1 is 6%. Applicable rate for year 1 to 3 is 8%. Both 6% and 8% are per annum rates. 6% can be identified as Z1 and 8% can be identified as F1 comma 2. So if you are investing or borrowing $1,000 at present, its maturity value after 1 year will be 1060, and that we got as taking 1000 into 1.06. However, if I want to arrive at its maturity value at this point, I must take 1060. To that I apply 8% compounding for 2 years. That means 1.08 raised to 2 should be multiplied to 1060 to get the value at third year end, and that value comes to 1236.384. So if I connect 1000 with this, I'll be able to get the connecting rate as Z3, and we have learned how to determine Z3. I am just going to prove the forward rate model and forward pricing model through this example. Let us move ahead and now compute Z3. I have already explained this to you earlier. 1000 into 1 plus Z3 raised to 3 would give you the maturity value, that is 1236.384. Through this equation we can find the value of 1 plus Z3 raised to 3, which comes to 1.236384. And when you want to compute 1 plus Z3, it will be 1.236384 236384 raised to 1 by 3. When you apply the calculation, 1 plus Z3 becomes 1.073292. So Z3 will be 1.073292 minus 1. That will be 7.3292%. Let us move ahead and do the important calculation. Z1 is 6%. Z3 we now got as 7.3292%. So we can compute P1 and we can compute P3 as well. Now based on the forward pricing model, what we have learnt, let us try to apply that. We draw a timeline with 0, 1 and 3 years. If the par value of the bond that you get as maturity value after 1 year is $1, its present value will be 0.9434, that is basically P1. Likewise, if you get the maturity value or the par value of zero coupon bond after 3 years, so you get $1 after 3 years, its present value will be 0.8088. So what will be the present value of this $1, not now but at 1 year point? That we have to find out. So the present value of $1 that you will get after 3 years, but you don't want the present value now, you want the present value at this point. This itself is capital F 1, 2. And how do you determine that? You compute that by taking P3 divided by P1, and that computed value comes to 0.8573. Let us move ahead and continue the calculations further. If we consider F1, 2, it can be computed by taking 1 divided by 1 plus small f1, 2 raised to 2. Through that, we can actually compute the forward rate, correct? That is the forward rate applicable for 2-year loan starting in 1 year. That is small f1, 2. And when you try to make the calculation through this equation, you get the value of f1, 2. Through this equation, you can determine that. So 1 plus f1, 2 whole raised to 2 is 1.166405. So when you take the square root of 1.166405, you will be getting the value of f1, 2. So 1 plus f1, 2 is 1.08. So f1, 2 will be 0.08 or 8%. Now this we have obtained over here, but we initiated the whole example through this rate. Let us move ahead and continue further. Alternatively, as per forward rate model, if you apply that notation and substitute the values, I explained to you earlier that we are going to start in 1 year for a period of 2 years. So if there is a bond that will initiate after 1 year for a period of 2 years, the applicable rate will be F1, 2. And because this is a 2-year rate, to compute the factor, it will be 1 plus F1, 2 whole raised to 2. That will be multiplied to 1 plus Z1 raised to 1. And eventually it will give you the value of 1 plus Z3 raised to 3. This is indeed the forward rate model. So we already knew Z1 and Z3, correct? So let us substitute the values of Z1 and Z3. And when you do that, your missing value in this whole equation now is this F1, 2. So we can easily determine that. So 1 plus F1, 2 whole raised to 2 will be 1.1664. And when you determine 1 plus F1, 2, it will be 1.1664 raised to 1 by 2. Or you can simply call it as square root of 1.1664. That gives you 1.08. So F1, 2 will be 8% per annum. So it is proven from these calculations that all your connecting points, that is the forward price and forward rates connected through the spot price and spot rates, are all matching. And through this no arbitrage pricing, we have arrived at the forward pricing model, which is a very, very important concept. In the follow-up class, what I'll do is I'll take more questions for you to practice out. But as of now, I am putting an end to this entire class. So you may quickly take note of this whole thing. And once you have taken note of this whole thing, consider that as end of this class.